do some simple math. I suggest to anybody who starts to do this type of work to get you a simple 4-function calculator, or you can use your telephone or whatever device you need as a calculator. It makes things a little bit easier. Going to go over how we calculate rates for fertilizer. If you look at the PowerPoint that we went over in the video, the formula is want over have equals need. And this particular formula is extremely helpful when we start to calculate all different types of rates when it comes to fertility. It's a method that I learned from a teacher at Virginia Tech, and over the last several years in doing recommendations for folks, it kind of has been the one thing that I can honestly say I use it more and more, and find that it gets easier and easier as I go through it. So looking at this particular question, it says Jim is has been contracted by Chickahominy Middle School to apply the fertilizer needed for their spring grow-in of their perennial ryegrass soccer field. Square footage of that field is 67,100 square feet. Based on the soil test results, we recommend that the middle school use a 10-18-10 fertilizer applied at a half pound of nitrogen per 1,000 square feet. We typically will always make recommendations for fertility based on the amount of nitrogen that needs to be applied. Why? It's because it's the most readily used nutrient, and it's also because it is the quickest nutrient to leach out of the soil. So how I would write this program, this particular formula up, so the want is you want to apply a half pound of nitrogen, so it would be 0.5 over, and then what you have 10% nitrogen in that bag of fertilizer. So the decimal equivalent to 10% would be 0.10. So if you take a calculator and you divide 0.5 divided by 0.10, you end up getting 5. And that's 5 pounds of that particular fertilizer, so 10-18-10 fertilizer per 1,000 square feet. Okay, so that means if I reach in that bag, I'll dig out 5 pounds of that fertilizer. I take that 5 pounds of fertilizer and spread that over 1,000 square feet. We don't have 1,000 square feet. We have 67,100 square feet. So if I take 67,100, divide that by 1,000, end up getting 67.1. So I take the 5 pounds per 1,000, multiply that by 67.1, and when I get 67.1 times 5, punch that into the calculator. Calculator tells me that I get 335.5 pounds. Okay, and I always just do per area. Okay, so if I was to answer this question, to do that single application over that size of field at that rate with that fertilizer, then I would have to purchase 335.5 pounds in order to cover that field. So what's the total number of pounds of fertilizer needed to achieve the desired rate? So that answer would be 335.5 pounds. So if we were in a situation where we could only buy 50-pound bags of that fertilizer and we weren't buying it loose, like a tractor-trailer load wouldn't show up and dump out 335 pounds for us, we'd have to convert that to the number of bags. Well, typically, the standard bag for fertilizer when it comes to ag or commercial grade fertilizers is a 50-pound bag. So we take 335.5, divide that by 50, and that gives us 6.71 bags. Well, you can't buy 0.71 bags anywhere. And if you had a scale, you could kind of measure it out maybe. But a good rule of thumb would be that that converts to 7 bags. So I would have to buy 7 bags of 10-18-10 fertilizer to cover my area. Now, if I were to take this another step further, if I asked the vendor to buy, to sell me that amount of fertilizer, I need to know how much it costs. Well, if it's $10.95 per bag, then we can do the math on that. So multiply 10.95 times 7. And then that gives us $76.65. So for me to do one application at 7 bags for $10.95 per bag would cost me $76.65. Okay? And that's how we figure that. Now, if I had a recommended rate of 1.5 pounds, okay, and I was still using the same 10-18-10, so 1.5 pounds of N needs to be the recommended rate. That would be 1.5 over 0.10. That means I would need to put down 15 pounds of that per 1,000 square feet. So just understand that, how we convert our rates. Okay? That's a basic demonstration of how we calculate rates. And this would be no different. If I said you need to put so many pounds of P2O5 down, you would calculate the rate based on the number that you see there. You can do this for any of the potassium, phosphorus, whatever particular element you're trying to apply. Typically we do nitrogen, but if it's an incomplete fertilizer and we only have phosphorus or potassium that's in that bag, then we have to calculate it for phosphorus or potassium. So that is our work on how we answer the questions. You will have a section in the assignment page with a series of math problems, and you'll need to show that work. So if you have any questions, please email me, or if you need another demonstration, please email me that as well, and I will be happy to do another video to show you guys how to do it. So thanks, and good luck.